All right, scholars, we're now here on the second page. I'm going to talk to you about why they call the point of concurrency for the perpendicular bisectors a circumcenter. Now, here's the part that I love, and it's actually, this vocab is very helpful for second semester. The circumcenter of triangle ABC is the center of its circumscribed circle. What does that mean? Circumscribed means it goes circumference-wise. It goes on the outside. So notice the circle goes on the outside of the triangle, but the triangle's vertices always have to be on the circle. We would describe the triangle as inscribed. So triangle is inscribed because it's on the inside, but its vertices are touching each side. And then the circle is circumscribed because it's on the outside. Circumference, kind of like think about circumscribed like the circumference. So then when you think of circumcenter, it's the center of the circumscribed. So you notice the same terminology there. We got the circum is going to be that center. Now, how can I truly, show that that works? But oh wait, I totally forgot here to write in the definition circumscribed about the polygon. So I'm using that word. And be very careful. If you're not careful, you will say circumcised, and that's so not what you want to say. Sorry, a little bit of humor there. But let's go ahead and let's show how this triangle ABC's perpendicular bisectors really do intersect at that point. So I go to the midpoint of my triangle, and I draw in the perpendicular bisector right here. So you can see the 2 points there, our midpoint and our two congruent segments. So I move the side so it's parallel to me again. I do the same thing. I do the right angle, and I get my two congruent segments, and you can see it goes right to that point of concurrency, the circumcenter. And I'm going to do it again. I'm going to go, okay, where's the halfway part? About right there. I'm going to draw it in again, and I'll make sure I get my right angle. And if you notice, they definitely intersect all at the same spot. So the circumcenter, you can see, is the center of that circle. So it kind of makes a little bit of sense. Now we're going to use a couple things now. This is the only type of problems you will see me ask you about the circumcenters, like calculating where they're located. And I'm only going to use the ones that work with the right triangle. Now remember, on the other side with the right triangle, we showed how it was the midpoint of the hypotenuse for the right triangle. So the key with these, and your homework problems, I think 1 through 7, all basically, they best describe how to do this. So these, no different terminology, typograms, even the directions I think match. And this is what you'd have to do on your quiz on Friday to be able to find the circumcenter. So just make sure you have that. All right, so first of all, I want to find the circumcenter of triangle HJK that has the vertices 0, 0, J is at 10, 0, and 0, 6. So the first thing you're going to do is you're going to want to graph paper, or at least rough graph this. You're going to want to draw the triangle. And then remember, we can find the circumcenter by drawing in the perpendicular bisector. So the cool thing about right triangles is that it's very easy to find the midpoint of the two legs. So I go over here, and I'm going to do this side first. And I go, all right, I'm going 1 through 6. Well, halfway is 3. If I do the perpendicular bisector, you can see it right here. You can see it hits the point, looks like the midpoint of our hypotenuse. So I go over to my other leg, and I go here 1 through 10. Oh, halfway is 5, and I got to draw it so it has a right angle there, and it goes through that point. You can see that the two lines are going to give me my point of concurrency. And if I wanted to, I could draw in the third line, but it's really not necessary. This point, 5, 3, is my circumcenter for that triangle. Now, I'm only going to do it with right triangles. And remember, on the other side, right triangle circumcenters are always the midpoint of the hypotenuse. So that means if I know the endpoints, like here that one's 10, 0, This one is 0, 6. So if I know the endpoints of the hypotenuse, I could just use the midpoint formula. So I would still always graph what I'm looking for in the midpoint formula. So I go over here, and I go 0 plus 10 over 2, because it's the average of the x's, and I get the average of the y's. So I end up getting 5, 3. Notice I get the same point if I graph or if I use the midpoint formula. Now, I'm not one, as you know, to always accurately graph, so for me it's normally better to use the midpoint formula. But then we have problems like this. Oh, look, it says find the center of the circle that you can circumscribe about the triangle with the vertices 0, 0, negative 8, 0, and 0, 6. Okay, I have 3 points of the vertices of the triangle, like what you'd see up here, A, B, and C. I have those, but how do I know which ones are going to be the endpoints of my hypotenuse? You don't unless you graph it. So you want to graph it. So I go over here, and I'm going to go, all right, I can do this. I'm going to do a quick graph. Here's X, here's Y. And you notice I'm not going to be overly accurate. I just need to get it in. One point's at 0, 0. The other point is at negative 8, 0. So somewhere, let's call that one right here. Oops, wrong spot. I'm totally graphing the wrong spot. Hello. Negative 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. All right. Make sure double count myself. All right, there's negative 8, 0. I can totally do graphing today. I'm doing this about 9, 12 at night, so it's my fault for not paying attention more carefully. And then I have 0, 6. So 1, 2, 3, 4, 5, 6. And so here's my triangle. Now obviously, if I'm looking at this carefully, you should be able to tell which side is the longest side. We know that's going to be 0, 6. It's going to be the hypotenuse. So for me, yes, you could draw in the points and try to figure it out that way, but I think it's just easier to do the endpoints and go negative 8 plus 0, and then I go 0 plus 6 over 2. So when I do that, I end up getting negative 4, 3. And if you look at that, that's about negative 4, and my really horrible drawing is 1, 2, 3. It's even almost where I drew it. Otherwise, you have to draw the perpendicular bisectors of all the sides, and here I can just calculate the midpoint. So it's going to be at negative 4, 3. Now I'm going to do the same type of thing for the third one. Again, I'm looking for the center of the circle, which we know is the circumcenter of, our inscribed triangle. So I'm going to still do the same process. I'm going to draw roughly my graph. I have a point here at 1, 7. So there's 1, 7. I have another point at 1, 1. And I have another one over here, 2, 3, 4, 5, at 5, 1. So if we have this triangle, this is what it would look like. Now, looking at that, and remember, I will only, again, let me reiterate, ask you to do this for right triangles. So if that's the case, you should be able to tell, here's my hypotenuse. It's my longest side. And we'll even talk about that later in lesson 5.5 about how we can tell longer sides or shorter sides based off of what we know about angles. So it's kind of important to know. But I'm going to sit there, instead of drawing this out and worrying about it, I'm going to do the midpoint formula again. So it's the average of the x's, so 1 and 5. So 1 plus 5 over 2. And then I have the average of the y's, so 7 and 1. So 7 plus 1 over the 2. So what do I get? 1 plus 5 is 6, divided by 2 is 3. And then I get 7 plus 1 is 8 divided by 2, which is 4. So my point should be 3, 4. Now if I was to graph this quickly, even though I did a horrible job of graphing it, I still got the circumcenter if I drew in the perpendicular bisectors to be the same thing. Now one thing I was asked is, does it matter if I use the midpoint or if I draw it to find what that circumcenter is? It really doesn't matter, but you have to be more careful when you draw the perpendicular bisectors with the right angles. Well, hopefully that helps you get the information down and you can use it to find your circumcenter with your notes.